Okay, now it's audible.
Yes, sir.
Hello. Okay. Okay. So now, last class we discussed about schedules. Okay. Schedules means those are what, combination of transactions. Okay. That is a view where you can see how many transactions are currently occurring and what are the different operations under the transaction. One minute. Okay. So schedules are nothing but collection of transactions which uh, shows that how the transactions are interleaved, or either they are serial or interleaved transactions. Those things we have seen in the last class, right? This was some specific examples that we have seen. This is a serial schedule. This is also a serial schedule. Now, if you remember, what do you mean by serial schedule is that the operations in a transactions are completed entirely, then another transaction starts. Like these are the operations under transaction T1. They start and they finish whole fully. That means T1 transaction is over, then T2 transaction is starting. Similarly, here T2 transaction is getting over first, then T1 transaction is starting. This is serial manner they are getting executed. First this one, then this one. In this case, first this one, then this one. Okay. This is another example of an interleaved schedule where the operations are interleaved. That means they are time separated. Fine. This is at T1, this is at T2. Then this is the first operation of T2. This is occurring at T3 second. This is at T4 second. So they are operating, they are executed in an interleaved manner. Fine. So this is an interleaved schedule. This is also an interleaved schedule. Now the problem is that we saw last class that these serial schedules are always fine. That means they always produce consistent state of the database after the transactions are complete. Okay. So they pose no problem to the database. But when we come to interleaved schedule, they may create problem. They may take the database to an inconsistent state, like this one was not proper, but this one was proper. So how do you know that which interleaved schedule is good? Because that day we also saw that serial schedules are not better than interleaved schedules. Interleaved schedules are always preferred. Even if serial schedules are always producing right result and taking the state from one consistent state to another consistent state, still they consume more time. that will make the resource of the database wait when there are a lot of transactions. So it will consume large amount of time. But if you have interleaved schedules like this, which take the database from one consistent state to another consistent state, and also they uh, generate proper result along with taking less time. So interleaved schedules with this type are preferred. So how do you differentiate between these two? That is, which schedule is better? So for that, we have a concept called serialized schedule. Serialized schedule means the result of this interleaved schedule should be similar to a serial schedule. So you see the transactions here is same as this. The transaction here is same as this. That means the T1, T2 transaction is same as this. Only difference is that this is interleaved in a arranged manner, whereas this is serial schedule. This is also same T1, T2, but these are arranged in an inconvenient way. That means this is the arrangement of operations are not proper. That is why this was creating problem. Okay, so now uh, yeah, about serialized schedule. Serialized schedule means the result of an interleaved schedule should be equivalent to the result of an serial schedule with another condition. What is the another condition, that we'll see. So first thing is, when we talk about serialized schedule, that means an interleaved schedule like this should be producing similar results as a serial schedule. That may be this or this. Okay, that you have to check. The example that we saw last class, this one. Yeah, the definition of serialized schedule is a schedule S of n transactions. Here n is 2 because T1, T2 there are two transactions. A schedule S of two transactions is serializable if it is equivalent to some serial schedule of the same n transactions. You see, serial schedule of two transactions is equivalent to this serial schedule. Okay, because the results are same. So that will be your serializable schedule. Okay, then how do you find, means how we say that these two are same or these two will produce same result? For that you need to know what is, there are two types of serializability. Okay, first thing is conflict serializability. Conflict serializability means uh, the two schedules are conflict equivalent, then you can say that they are conflict serializable. Now again, coming into the detail, what is conflict? Conflict means this type. Say in one transaction, see the same transaction. Conflict means if there are operations in two transactions where one involves write, another involves read. Here X is a data item where this transaction T1 is writing, then again after that T2 is reading that data item. Okay, then here X is getting written on by T2, then further nothing is there. Okay, um, so conflicting operations are read from one side, write on another side. So this read and this write will be conflicting, this write and this read will be conflicting. Read will not be conflicting because they are not changing the value of X. Whenever a value of X is getting changed in any one of the transactions, then that will involve conflict operation. Here this is the operation of T1, this is the operation of T2. Okay, now this is reading the data item X and this is writing the data item X. So these two are conflicting instructions or conflicting operations. Similarly, this is writing the data item X, this is also writing the data item X. So these two are conflicting operations. This is reading the data item X, this is writing the data item X. These two will be also considered as conflicting instructions. Okay, so when first thing is that You have to find that whether there is any conflicting instructions, conflicting operations existing in the transactions or not. Suppose this is on X, this is on Z, this is on Y. So there is no conflicting instruction. This may be right, this may be read, but this is on separate data item. This is suppose on Z. So these two are not related. Okay, they are not conflicting. When it is getting conflict? Now when one of them involves write and they are on the same data item. Here this involves write, same data item X and X. This involves write, same data item X and X. This involves read, this involves write on same X. So this is conflicting, but there is no conflict between these operations. Write on X, read on Y, no conflict. Write on X, write on Y, no conflict. But had it had been, it would have been X, then this write X and this read X would have been conflicting. Now you know, is it clear or not? What is conflict? Where you are finding conflict? This is not conflicting because this is on X, this is on Y. This is not conflicting because this is X, this is Y. This is conflicting. Write X, write X. This is conflicting. Write X, read X. These two are conflicting. Read on X, not conflicting because these are read. Not even a single write is involved, so these are not conflicting. So you see the conflict with respect to the operations, not with respect to the transactions. Okay. Each individual operations you have to check. Okay, fine. Yeah. The conflict serializable is said like this: we define a schedule S to be conflict serializable if it is conflict equivalent to some serial schedule S dash. In such a case, we can reorder the non-conflicting operations until we form the equivalent serial schedule. That means you have to try to convert an interleaved schedule into serial schedule with respect to the conflict operations. If you can do that, then that is a serializable schedule. In simpler sense, the meaning is that I will try to convert this interleaved schedule into any one of this or this serial schedule by rearranging the instructions. If I can do that, then this is a serializable schedule. Got what I mean to say? Are you still connected? I am in doubt this semester. No, you people are so silent. Most of the time I think I will stop this online class. Yesterday we submitted a report. I had already 23 online classes for this course. But every time I feel like I will not take further class in online mode, I will just give PDF because you are not even replying anything. Yes, no. What is the issue with all of you? Is it a boring subject or you are not understanding or what is the problem? Database is a subject which is too fundamental. As I said in the first class, in GATE question, in any of the GATE year you take, at least 7 to 8 questions you'll be finding from database. बुलबुल कुमारी समझ में आ रहा है कि नहीं?
सर लेकिन सर मुझे ये वाला आया
हाँ?
समझ में और बाकी जो आपने जो पढ़ाया था ना क्या था वो
सुनाई नहीं दे रहा है, जोर से बोलो।
हेलो सर, ये वाला ना ट्रांसलेशंस वाला ना मुझे थोड़ा-सा समझ में आया, लेकिन जो आपने इसका आगे पढ़ाया ना जैसे शेड्यूलाइजेशन नहीं स्कीमा का फैक्टर्स वो सब में थोड़ा डाउट है। और कहते हैं वन वन नॉर्मलाइजेशन, टू नॉर्मलाइजेशन, थ्री नॉर्मलाइजेशन, फोर, थ्री तक समझ में आया। फोर और फाइव नॉर्मलाइजेशन का मुझे थोड़ा डाउट है।
देखिए मैं तो हर बार बोलता हूँ, जो भी डाउट है तुम इसमें लिखो। फोरम में लिखते ही नहीं हो, कुछ भी रेस्पॉन्स नहीं किसी के तरफ से, कोई सिंगल स्टूडेंट है नहीं, एक दो ही हैं जो
और
व्हाट्सएप भेजते हैं बस।
सर एक चीज बोलूं,
बाकी मिल
एक्चुअली
जाता
मुझे ना, सच में बोलूं तो मुझे प्रैक्टिकल में ना, मतलब प्रैक्टिकल लिखना आता है लेकिन रन कराना नहीं आता है। मुझे सच बोलूं तो मतलब मुझे, मैं मतलब क्या करूं, क्योंकि मुझे सीखना है। अगर मैं झूठ बोलूंगी तो नहीं होगा, क्योंकि लाइफ में मुझे कम मार्क्स भी मिलेगा, मैं चलेगा, लेकिन मुझे सीखना है, किसी को सिखाना है। तो इसलिए मुझे सिखा दोगे एक बार ऑनलाइन क्लास से? किसे उसको मतलब कोडिंग लिखना आता है, उसको कैसे रन कराता है नहीं आता है माई स्क्वेल्स में।
जो बोला जा रहा है वो सब समझ में आ रहा है कि नहीं आ रहा है?
हाँ वो तो आ रहा है।
अच्छा, ठीक है, ठीक है, तुम्हारे ऊपर है, सब लोगों के ऊपर है। तुम सीखना चाहते हो तो सीखोगे, नहीं तो फिर ऐसे ही कनेक्ट करके बैठे रहो। मुझे कुछ बोलना नहीं है। ओके, सो thing is that how you will say that this interleaved schedule is conflict serializable? What is the way? Now you have to try and arrange these instructions in such a way that you can convert it to either this serial schedule or this serial schedule, because there are two transactions involved. There is only two possibility, one is this, one is this serial. So try to shift. Can I shift this? I have to either perform T2 first or T1 first, because in order to have a serial schedule, either T2 will be completed first or T1 will be completed first. So if I am converting into a serial schedule, either this 3 I will move downwards. First I will complete this 6, then this 3, or I will move this 3 upwards and this 3 here, so that first T2 will be completed, then T1 will be completed. Which one is acceptable? So in order to shift these 3 up, what I will do is that T3 is having right item X, that means at time unit 3 this is getting performed. Suppose I will keep it to 4, time unit 4, this I will move up to this place. Okay, what will happen is that this will fall one place down here, this will go up one place to here. Is this possible? If I do like this, I will take this up to here. That means this 3 will be writing here, this 6, this 3 I will be writing here, so that T2 will be completed first, T1 will be completed next. Is it possible? No, it is not possible, because the conflicting instructions are not changeable. That means if there is a conflict between this cannot go up and this cannot go down. Fine. I cannot move write item X to one place down. I cannot move read item X to one place up. Getting? That means these are conflicting instructions. Am I clear or not?
Yes, sir.
Hmm?
Yes, sir.
Is it clear or not clear? कोई कुछ भी नहीं बोल रहा है। क्या हो गया तुम लोगों को? बाकी जितना पार्ट है, मैं ऐसा करता हूँ, तो लिंक है ना एनपीटीएल का, वो दे देता हूँ, तुम लोग खुद पढ़ लेना। डाउट है तो मुझे पूछना, डाउट क्लियरिंग क्लास में कर लूँगा। ये कोई रेस्पॉन्स ही नहीं है तुम लोगों का, फिर क्या मतलब है? लिखो, इस बार एग्जाम लिखो, फिर पता चलेगा तुम्हें। अब डाउट आएंगे तो okay. This is T1, this is T2. Fine. I want to convert this into serializable schedule. A serial schedule will be like this. Table. Either this one, no, first T1, sorry, first T2, then T1, okay, or first T1, then T2. Fine. Now this is a serial schedule, this is a serial schedule. I will rearrange these instructions in such a way that I will try to convert either this to this or this to this. Which one? So for that, I will skip one by, I will do one by one. This item, this particular operation of T2, I will perform at time unit 3. This will come down by one place to time unit 4. Okay. Now again, this will go up by one place. This will come down by one place. Now similarly, this will go to say 2. This will come to here. This will go to here. Okay. Now this will go to here. This will come to here. Now this will move up by here. This will come down to here. Now this one is left, so this will also similarly go one by one here. This one will come down to here. Okay. This one will further go to, getting or not? I'm moving one by one. Okay. This one will come to here. This one will come to here. Fine. Now you see, this one I managed to convert it into this type of serial schedule. Fine. Now if I can do something like this, then the interleave schedule which we started with is an serializable schedule. Okay. If we cannot do, then it is not a serializable schedule. Getting or not? Okay. So the way I moved those operations to up, is that allowed or not allowed? That one I was asking.
Not allowed.
That means these were here, no? And these were here. And this is here. That is allowed or not allowed? That allowed or not allowed, you have to check by checking the individual operations. This with this. Whether initially you can take this up or not, whether you can do this first step or not, that you have to see. Whether you can move this up and move this down or not. You cannot do this thing because read and write are conflicting operations. If they are moved or changed in this way, that is not allowed. Okay, that means these things will be here and this thing will be here only. You cannot move this up and move that down. But so if this cannot move up, this cannot come down, so entire this 3 cannot move up. There is no way, no possibility. So let's try to move this down so that these will move up, so that all these will be here. And all these will be here. This is also a serial schedule. Can we do that? Let's see. Write item X, read item Y. Who is joining now? Okay. Now is this two operation conflicting? This and this? Are they conflicting?
No.
No, because this is a write on X, this is a read on Y. These are not conflicting. So you can do that. You can move this to here and this to here. Okay. Next, these two are also not conflicting because this is a update operation. You can do it. And again, these two are not conflicting because this is read, that too on separate data item. Okay. Similar now, these two are not conflicting because this is separate. Now these two are also not conflicting. This also can be moved up. These two are also not conflicting. This can come down. This can still move up. Fine. Now right. These are also not conflicting because this is on X, this is on Y. Had it would have been on X, this is also X, then that would have been conflict. But this is on X and this is on Y, so this is not conflicting. Similarly, this is not conflicting with this. This is not conflicting with this because this is on X read, this is on Y. So this entirely can move up to here, and these 3 can be moved down to here. So now this got a serial schedule. Okay, the previous serial schedule like this was not possible, but this is possible. So you converted an interleaved schedule into a serial schedule. Now the result will be equivalent. If you can do this type of shifting, then this schedule is a serializable schedule. But you try to do this, either this all up or this all down, it is not possible. You cannot do that because you see here, suppose I am trying to move this all up. Write item X will not be conflicting with this, but it is conflicting with this. So it cannot move up. Similarly, read item X with write item X, it is conflicting. So this cannot move down. So neither you can move this up nor you can move this down. So none of the operations are changeable. So these can never be converted into a serial schedule. That means this is not a serializable schedule. And if this is not a serializable schedule, then that will always produce inconsistent state for the database. Okay, but this you saw that it can be converted to this type of serial schedule. So this is a acceptable serializable schedule. Fine. Now you know that how these conflicting instructions or conflicting operations help in order to find whether a schedule is serializable or not. Fine. Any doubt in this? No doubt. Okay, there is a uh, simpler way in order to see that whether your schedule is serializable or not. By means of drawing a graph, you can know it. No need to shift those individual operations up and down. Fine. The graph will be drawn by means of this uh, algorithm. First thing is, for each transaction, you have to draw a bubble. Okay, how many transactions were there in the schedule? Two transactions, T1 and T2. So for those schedules, the graph will have two bubbles because there are two transactions. Fine. Okay. Then wherever there exists this kind of thing, that is read item X in one transaction and write item X in another transaction, you have to create a edge. Create an edge. If there is a write in Ti, read in Tj, then the edge will be from Ti to Tj. One second. So when you can create an edge, whenever there is read in one side and write in another side, or write in both side, then you can create an edge. See the example. This is the graph for schedule, the first schedule, schedule A. That means this one, this one. Why? Because here it is read item X. Now there is a write item X here. So read and write will have an edge. Similarly, write and read will have an edge. Fine. So there will be an edge from T1 to T2. Similarly, for this schedule, there will be edge from T2 to T1 because here read is there, write item X is there. Here write item X is there, read item X is there. So T2 to T1, but there will be no edge from T1 to T2. Here also there will be no edge from T2 to T1. Okay. You see here the graphs for schedule A, schedule B, T1 to T2 for this side serial schedule, T2 to T1 for this side serial schedule. Based on which data item? Based on X. Now for schedule C, the graph is like this because read is there, write is there. Here read is there, write is there. Here you see read write means not only read write, you have to see the data item. These are on the same value, same variable X. Okay, so age will be from T2 to T1, age will be from T1 to T2. In this case, age will be from T1 read to T2 write, T1 write to T2 read, but there will be no age from T2 to T1. Fine. So the graph for this one will contain only one edge, T1 to T2. This will contain two edges from T1 to T2 and T2 to T1. So whenever in the graph you will find a cycle, that means that schedule is not serializable. If there is no cycle present, that schedule will be serializable. Okay. Now you know the difference, that what is a uh, What is the quick test for saying whether a schedule is serializable or not? You have to just draw a graph. If the graph contains cycle, that is a serializable schedule. Sorry, it is not a serializable schedule. If it does not contain any cycle, that is serializable schedule. Okay, now all of you uh, tell me this answer of this question. There are still 10 minutes left. You draw the figures and tell me which of these is serializable, which of these is not serializable. Last class I told you how to represent this in terms of the schedule diagram, the table. So do it now. I'll be waiting. You have to show the answer. The question is on the screen. Any problem, anyone? Sorry. This one. Question number 21.22. Let me see.
First one is not serializable.
क्या हुआ?
First one is not serializable. Okay.
How many transactions will be there?
Sir, there will be a loop between T1 and T3.
No, how many transactions are there?
3.
Three. Okay. R1 or three. Cycle between whom?
Between T1 and T3.
R1. Anyone else? Any answer? 10 minutes are there.
First one is not non-serializer. Uja. There's a cycle between T1 and T3.
Wait, I will ask one by one. R1X, R3X, W1X, R2X.
Sir, is the second one serializable?
What?
Is the second one serializable?
Actually, I want to know answer from all of you. Then I will tell the answer. I have drawn the answer. The question is quite straightforward because they are all operating on the same data item. So not much confusion will arise. Just you have to draw the schedule in the tabular format. Then you can see the loops are existing or not. So I will start with the first Ades.
Yes, sir. I'm still trying to draw it, sir. And if you can ask me a little bit.
No answer.
Yes, sir. Can you not hear me?
Yes, I could hear you, but
Yeah.
there's no answer from your side. Means you could
Yes,
not
sir.
answer it.
Yeah, but sir, I'm still doing it. I can show you my paper once I'm done, sir. But I'm not sure whether it
Anamika.
will be correct.
Anamika.
So I'm still doing.
Asa.
First,
Asa Kumari, could you complete?
sir, first is serializable.
Hmm?
Sir, for me,
First,
first is serializable. Yes, sir.
only first one. Okay. Ashwini Kumar.
So I'm still doing it.
Bulbul Kumari. Bulbul Kumari, could you complete or not? Hari Babu.
So first one and second one, I think
First one is what?
first one is non-serializable.
Okay. Second one.
Second one is serializable, sir. And the last one I'm doing, sir. Third one is also serializable. I think the last one I'm still doing, sir.
First one you told non-serializable. Third one you told serializable, but you are not sure.
Yes, sir.
Okay. Second one you told is serializable.
Yes, sir.
Okay, that means you have Monica. Monica went off. Okay, whoever was present went off. They can also be gathered. That means that information is there in Google Meet that when you are joining and when you are getting off. So there is no point. During the starting, there are more than 20 people. Now,
अरे सर
yeah,
सर मुझे नहीं पूछा आपने
पूछ चुका था ऑलरेडी.
नहीं एक्चुअली मेरा वो लेनोवो
Sir,
अच्छा तुम आंसर
uh,
बताओ. Yes.
sir, A will be non-serialization and B also non-serialization and
कॉल
C
आया
will be
था इसीलिए मैं
serializable,
बात
sir.
कर रही थी
I think.
Okay. D.
These are. I'm still. So I'll tell you in a while, sir.
Bulbul Kumari, what is the answer?
Not serializable, sir.
Which one?
A.
Then
Um,
B.
B. B is also not serializable. The reason is that क्योंकि रीजन बताना है
नहीं, बस आंसर बताना है, सी और डी में से।
This is also not serializable and D is also not serializable. कोई भी नहीं है।
Sir, I think B and C are serializable, and A and D are non-serializable.
Sir, for B, T1 actually reads X. But it should be non-serializable, I think. I don't know.
Who? What? Last one. Who spoke?
Sir, this B, I don't think it is serializable. It should be non-serializable.
Which one? Which one?
B.
B.
Yeah.
B is serializable.
No, non-serializable, sir, for me.
You completed ABC. Only D was there.
Also, sir, they're all correct.
D was serializable or not as per yours?
Sir,
Nikhil Singh.
Uchi.
Yes, so for me, only C is conflict serializable, and rest are non-conflict serializable.
Okay.
सारा serialization की मतलब
Rusali.
So I got B and C serializable and A and D non-serializable.
Okay. Then next, Sunny Kumar.
Sir, serializable.
Sir,
Which one serializable?
Sir, C.
C and
Sir, I think only C is serializable and D too.
Ved.
According to me, C is serializable and all rest are not.
sir,
Yeah.
sir. Even I got C serializable. In B, I'm by mistake I said it's serializable. It's also non-serializable.
Okay. So that is the correct answer. C only is serializable. Rest all are non-serializable because there are at least one loop for A, T1, T2, T3. The loop is T1 to T2, then T2 to T3, then again T3 to T1. Because T1 is having R1X, T3 is having W3X. So that you can relate. That is a edge. Then T3 is R3X, T1 is RW1X. Between that, you will have an edge. Then again T2 to T3 are 2x W3x. There will be an edge. Similarly for P also, T1 to T3 there will be a loop. T2 is not involved. T1 is having R1x, T3 is having W3x, and T3 is having R3x, T1 is having W1x. They will be having loop. R2x can also be involved. T3 is having W3x, T2 is having R2x. Yes, there will be a loop between T3. There will be an edge between T3 and T2 also, but there is no loop. So B will be non-serializable. Only C is serializable because there is only one edge from T3 to T1. D is
Excuse
also
me,
not.
sir.
Yeah,
Can you please repeat why D is non-serializable?
D is having a loop between T1 and T3 because T3 is having R3x, T1 is having W1x. Then T1 is having R1x, T3 is having W3x.
Yes, sir. Oh,
So the edge will be existing between T1 to T3 and T3 to T1. So there is a loop.
yeah, yeah. Yes, sir.
So they will not be serializable. Fine. As per that, you have to see the uh, complicated cases in the next question 21.23, which involves three variables x, y, and z. Okay, then you have to check their serializability as per this question. So you try these things. Okay. This is one type of serializability checking, whether they are serializable or not, because you know that serial schedules are always producing correct result and they are taking the database from one consistent state to another consistent state. So they are good, but they consume more time because if suppose you are doing it serially T1, T2, T3, then T4, T5 like that, and if one of the transaction in between is of huge length, it involves suppose 2000 or 3000 operations, then the next transaction which are of small size, they have to wait for that much amount of time. So that is a bad process. So instead of that, you have to do interleaved, you have to do with interleaved schedule, but they should be producing result equivalent to serial schedule. That's why you are checking which interleaved schedule is serializable. That schedule only can be accepted in a database. Those schedules which are not serializable, like here you saw A, A, B, and D, they are not acceptable. They will not be allowed. Okay, that is the reason behind checking whether your schedule is serializable or not serializable. Now there is another way of another serializability, that is called view serializability, that we'll see in the next class. Okay, then we'll go to locking concept. After this locking concept is finished, almost all the major components of the subjects are complete. So you take time and read these things from beginning. Wherever you have doubts, you note down and you can write it in the forum so that we can collectively uh, gather all the doubts to be cleared in a single or two or three or how many number of doubt class we can conduct in a week, no problem. But just list down your doubts. Fine.
yes, sir. Yes,
Only
sir.
single book. I am also telling you from the single book only. The ebook that I have shared. Every single concept of the BMS is there. So no need to go anywhere else. Just read through this book. Fine. We take the attendance. Okay, I took the attendance, stopping the recording.